Example 8. Now in these examples, we have the function f of x and g of x. The function f of x is a combination of a rational function with the absolute value, and the function g is just the absolute value function. Now pretty straightforward, the domain of the function g is going to be all real number, because we can take any x value, plug it in here, and we'll be able to crank out the corresponding y values of that specific x value. Now for the function f, we have a rational function, so the first thing that you guys will probably do is we take the denominator and set it not equal to 0. Now remember back in, like when you study absolute value, every time when you have absolute value of something only, and it is equal to a number, usually you guys like to do like 2x minus 5. Or in this case, instead of equal sign, we have less, not equal, negative, the negative of that number, or the same interior, but now it's just that number itself. Well, negative 0 is still 0, and 0 here is still that. So you guys would probably do something like this first. However, whenever whenever there's absolute value, what you like to do is that you want to recall the definition of absolute value. So recall that when you have absolute value of x, it is defined to be a piecewise function of positive x if x is greater than 0, 0 if x equal to 0, and negative x if x less than 0, if x is less than 0. Now, what about this? Well, if you have absolute value of 2x minus 5, then it can be written as a piecewise function of positive 2x minus 5 if 2x minus 5 is greater than 0. But this right here, if we solve for x, it is going to give us, let's see, I'm going to write like this. It is going to give us x is greater than positive 5 over 2. And it is going to be 0. This function will become 0 if 2x minus 5 equals 0. And if we solve for x, it's going to give us x equal to 5 over 2. Negative 2x minus 5 if 2x minus 5 is less than 0, which would say x less than 5 over 2. So using the definition absolute value function, that is how we crank out the piecewise version of this absolute value expression. So the denominator absolute value of 2x minus 5 is going to be equal to 0 if the x equals to 5 over 2. So really, we can tell for sure that the domain of this f function is going to be all real numbers except x cannot be equal to 5 over 2. So how do we sketch it on the number line? Well, let's see. Like that. And let's see, we have 5 over 2, like maybe in the middle right here. So let's sketch the domain of the function g first. It is all real numbers, so really it's pretty straightforward. From here all the way to positive infinity. So this is the domain of the function g. For the function f, it is all real numbers except x cannot be equal to 5 over 2. So really we are supposed to put the open circle at 5 over 2. And we're just going to make a solid line at every other part of this. So for the interval notation of the function f, pretty straightforward. parentheses, from negative infinity up to, but not including 5/2. So from here to here, that's that. Jumping to the next part, we'll put a union sign. And then going from excluding 5/2 all the way to positive infinity. Like that. Now what about the sum, difference, and product? Well, for f plus g, we have 3 over absolute value of 2x minus 5 plus absolute value of 3x minus 4, recognizing the facts that anything by itself is the same as itself divided by 1. I can find the common denominator, the least common denominator, which is the product of 1 and this. So all I have to do is multiply this denominator by this one. Equal. Well, the first one stay the same, 3 over absolute value 2x minus 5. And for the second one, I got absolute value of 2x minus 5 in the denominator. Now for the numerator, well, recognizing the facts that absolute value is just distance, so it's always going to be positive. And this one is also another distance that's always going to be positive. I can just multiply the expression 3x minus 4 and 2x minus 5 inside one common absolute value. So I got 3x minus 4 times 2x minus 5 inside the absolute value. So this is just a matter of foiling it out. So that means I'm going to have, let's see, 3, and I'm just going to put one common denominator. Let's see, that's going to give me, let's see, 3x times 2x is going to be 6x squared. 3x foiled to 5 is going to be negative 15x. Negative 4 times 2 is going to be negative 8x. Negative 15x plus negative ax is going to be negative 23x. Negative 4 foiled to negative 5 is going to be positive 20. But hey, this is just going to be 3 plus the positive of this whole thing. 6x squared minus 23x plus 20 all over absolute value of 2x minus 5. Combining like term, 3 plus 20 is going to be 6x squared minus 23x plus 23, all divided by absolute value of 2x minus 5. Now, let's go back and find all points of discontinuity at every step, because remember that we want to make sure that all of our expression, any one of our expressions cannot be undefined, because otherwise there's no way we can do the sum of the two functions. So at the first steps, well, we have this little fraction here. But earlier, we were able to find that x cannot be equal to 5/2. So over here, x cannot be equal to 5/2. This one, or this one will stay right there. For this one, yeah, same thing. This step say x cannot be equal to 5/2, and this denominator say the same thing. X cannot be equal to 5/2. And what about the next steps? Well, this absolute value is in the numerator, so any x value can go in here. But this denominator, yeah, x cannot be equal to 5/2. Same thing for this, and same thing for that. So all of the restriction of f plus g is that x cannot be equal to 5/2, and x is able to be all of the other real numbers.